Yeah, hi guys. So today we are going to solve few numerical problems, which is based on different types of graphs, and it is all related to motion in one dimension. So the problem number one, I have written down the raw data here beforehand. So it says that as per the here, I have written question number one. Okay, this we are talking about question number one. Question number one says that you have been given this particular displacement time graph. Displacement time graph, okay? And from this displacement time graph, you have to comment on the velocity of the object at 1 second, 2 seconds, and 3 seconds. So this is what is being asked. So they are asking to calculate. So by seeing this graph, what can we comment about the motion of the object? We can say that, see, in 1 second, if you see graph, total displacement made is 2 meter, right? So you can say that in first second, right? First second, total displacement is made is 2 meter, right? In 2 seconds, total displacement made is 4 seconds. So in second, you can say that second, you can say that again 2 meter displacement. How about in third second? In 3 seconds, it made a displacement of 6 meter. So in third second, you can say it made a displacement of 2 meter. And in fourth second, so likewise in fourth second, okay, the net displacement made by the body is 2 meter again. In fourth second, mind it, I am not talking about 4 seconds. I am talking about fourth second. I am talking about third second. So we see that object is traveling, is making equal displacement in equal time interval, in the same time interval. Per second, it is making a displacement of 2 meter. So we can, by seeing this data, we can say that the object is moving with a uniform velocity. Also mathematically, we can prove that fact from here also. If you go and take slope from this point, you will find certain angles. You go and measure the slope. You go and measure the slope. Anyway, right? So here, what we are required to find out is that uh, find the velocity of the body at t equal to 1 second. So can we write it as this way? Velocity of the body at equal to 1 second. So this is what? This is displacement by time. What is the displacement made in 1 second? Is 2 meter. 1 second. This is coming 2 meter per second. Similarly, it is asking for velocity of the body at 2 second and 3 second also. Velocity at the completion of t equal to 2 second. This time it is asking t equal to 2 seconds. So again, d by t, right? So what is the displacement made in 2 seconds? In 2 seconds, it made the displacement of 4 meter. 4 meter by 2. So it will give you again 2 meter per second, right? Thirdly, it is asking to calculate the velocity at the completion of 3 seconds, t equal to 3 seconds, right? Again, you can calculate in the same way, d by t, right? So the displacement made in 3 seconds as per the graph is 6 meter. So it is 6 meter by 3. So it will be giving you 2 meter per second. So at the completion of first second, second second, third second, velocity is same. And now it is asking us to draw the velocity time graph. So how to draw the velocity time graph of this? So here we can draw quickly. It is the time. I've taken time, or you might not be able to see. So now I can take it off this data, right? I can take off this data, and here I can quickly draw the velocity diagram. This is the time, in second, Okay, and this is the velocity in meter per second. Okay, so in 1 second it was traveling with the velocity. At the completion of first second, it was traveling with the velocity of 2 meters per second. Second, at the completion of 2 seconds, it is still traveling with the same velocity. At the completion of 3 seconds, it is still traveling with the same velocity. So velocity time graph in this case will look like this. Straight line. A straight line parallel to time. That means with the passage of time, you see the velocity is constant. So that we draw the velocity time graph. So we are done with question number 1. In question number 2, they have again given. They are talking about following table gives the displacement of a car at different instants of time. Displacement of a car at different instants of time. 0 at time 0, the displacement is 0. At time 1 second, displacement is 5 meter. 2 second, 10 second, 10 meter. 3 second, 15 meter. 4 second, 20 meter. So it is asking us to draw the displacement time sketch and find the average velocity. Draw the displacement time sketch. Okay. So 0, first point is this, 0 is to 0. Second point is 1 second, 1 second, 5 meter. Second point, right? Third point is this, 2 is to 10. Right? So let's go and read this point. Let's see what we are going to get. Third, at the completion of third second, 3 second, how much distance is traveled? Approximately it is t. At the completion of 4 second, it is saying that the distance which is covered by displacement is 20 meter, right? If you go and meet all these points, right? If you go and meet all these points, you find almost a straight line. You will almost find a straight line. So in this case, what can you say? What can you say about by seeing this displacement time graph? That in every second, body is making a displacement of 5 meter only. In second also 5 meter. Third second also 5 meter. Right? Fourth second also 5 meter. So in every second it makes a displacement of 5 meter. That means the body is making a equal distance in equal displacement in equal interval of time. Body is making equal displacement in equal interval of time. That means we can say that body is traveling with uniform velocity. So now what? So first part we are done. It was asking draw the displacement time sketch and find the average velocity of the car. Right? So in this case, when the body is traveling with uniform velocity, the average velocity is same as the instantaneous velocity, right? So we can find out the average velocity. How to find the average velocity? Average velocity is total displacement okay, total displacement by total time taken. Time taken. What is that? Total distance, total displacement mean it is 20 meter. How much total time it is spent? 4 seconds. So what is the value of the average velocity? 5 meters. So body is traveling away from the starting point at the average velocity of 5 meters per second because the velocity is coming positive. Okay, so now second part is saying that what will be the displacement of car at 2.5 seconds. At 2.5 seconds, approximately here we are, right? This is 2.5, so approximately from 2.5 seconds. Right? now we know the velocity. So, and we have been given the time, right? T equal to 2.5 seconds. What is the displacement? There are two ways. Either with the help of scale you go and measure this, or since you have calculated the average velocity, which is same as instantaneous velocity in this case, right? Because the slope is coming constant, right? Slope of the curve is coming constant. So here there are two ways you can solve the problem. You can find out the displacement as velocity into time, right? So velocity is 5 and time is 2.5. Here in this case you can say that it is total displacement made is 12.5 meter at the completion of 2.5 seconds. What is the displacement made at the completion of second case? It is saying that 4.5 seconds. Time interval is given as 4.5 seconds. So displacement at the completion of 4.5 seconds is, again it is V into T. So this time it is 5 and you have to multiply it by 4.5. Right? So this time you will get 22.5 meter. So this is the displacement at the completion of 4.5 meter. Sorry. So now, second question we are done. Third question is talking about a body is moving in a straight line and its displacement at various instants of time is given in the following table. Time 0 second, 2 meter, 1 second, 6 meter, 2 second, 12 meter, 3 second, 12 meter, 4 second, 12 meter. So here by seeing this we can say that body is not moving, right? So 0 second, 2 meter, first coordinate, second coordinate 1 second, 6, 2 second, 12. So that way we have to go and make this curve. So we'll make this curve in this way. Right? Right, and again. So approximately this is the velocity time graph plot. Displacement time graph, sorry I said velocity time graph. This is displacement time graph. It has been asked, plot displacement time graph from this raw data, right? And calculate total distance traveled in time interval 1 to 5 seconds. 1 to 5 seconds, how much distance is traveled? How much distance is traveled in 5 seconds? Okay, in 1 second to 5 seconds. Total distance traveled in 1 second to 5 seconds. So from 1 second to 5 seconds, we can go and calculate the form this kind of thing, and again this kind of thing, right? Okay. So we can say that at the completion of 1 second, the displacement made by the body is 6 meters, right? 1 second it made, at the completion of 1 second it made a displacement of 6 meter. At the completion of 5 seconds, at the completion of 5 seconds it made the displacement of 18 meter, right? So what is the distance covered? Distance is how much distance it is covered. It is made 18 minus 6, 12 meter, right? And average velocity in time interval 1 to 5 seconds. What is the average velocity? Part B. Average velocity in time 1 to 5 seconds. We calculate it. The average. It is same as total displacement right? Total displacement by total time. So that we can get calculate. Total displacement is 12 meter, and it is calculated the first part, and total time is 5 minus 1, 4. So it is coming